In this video, we will go over the nomenclature of an ionic compound versus a covalent compound. So our first example here is carbon dioxide. So a covalent compound is between two nonmetals. Carbon is actually a nonmetal, oxygen is a nonmetal. We name these with prefixes. So we have the prefix di, which represents two. So carbon is going to be one carbon dioxide. Oxide represents oxygen. Carbon dioxide is CO2. More importantly, we're talking about a covalent compound. Okay? Sharing of electrons. Our second example is calcium phosphate. So looking at our periodic table, calcium is in sort of the left-hand end of the periodic table. To the left of the staircase. Phosphate has the formula PO4 minus 3. Calcium, which is in group 2 of the periodic table, is plus 2. And for ionic compounds, we will do the switcheroo. The formula for calcium phosphate is calcium 3. The 3 goes to the calcium. This PO4 is one whole unit known as the phosphate ion, and it picks up the 2. Okay, this in essence is what switcheroo means. Lithium hydroxide is another ionic compound, so this is ionic. And we want to discriminate between what is ionic and what's covalent in this assignment. Lithium has the chemical formula Li, and it's plus 1 because it is in plus 1 of the periodic table. Okay, how do I know hydroxide? Again, our flashcards is OH minus. Anytime a plus interacts with a minus, that is an ionic interaction. And the formula for lithium hydroxide is LiOH. This is the hydroxide ion. All right, another big key to tell you whether it's ionic or covalent are these prefixes. So hexa is a prefix for 6. You may have heard of hexagon. So sulfur is S. Fluoride represents fluorine, which is F. And hexa is designated 6. So this is a covalent compound. It's a sharing of electrons, as opposed to the above two examples, which is a transfer of electrons. Iron 3 nitrate. If you're wondering why the iron is in Roman numerals, it's because it is in this box in the periodic table. Some textbooks also include this as part of the transition metals. Transition metals, they can be multiple charges, and when we name them with the charge designated in Roman numerals. So automatically Fe is plus 3. Nitrate is NO3 minus. That is what we get from our flashcards. This is an ionic compound. The 3 goes here. The 1 from the minus 1 in nitrate goes there. That is switcheroo, and so this is going to be Fe. And we're going to put parentheses NO3, close those parentheses 3. That is iron 3 nitrate, and this is ionic. Lead sulfate. So lead is situated right here in the periodic table. Can't really decipher a charge, but we do know that sulfate is SO4 minus 2. That is from our flashcards. And lead here, lead is actually plus 2. That's something we just memorize. If there was another charge, it would usually be designated by Roman numerals. But lead is typically plus 2. This is PbSO4. It is an ionic compound. The plus 2 and the minus 2 switch. And this is the lowest common denominator, the empirical formula. Silicon tetrachloride. The tetra should clue us in that this is a covalent. Silicon is Si in the periodic table, looking that up. Chloride represents chlorine. This is SiCl4 as the formula. Calcium bromide. Calcium is in group 2 of the periodic table. And group 2 of the periodic table has a charge of plus 2. These are the alkaline earth metals. Bromide represents bromine, and that is Br minus. Okay. Everything that is in the halogens are minus 1. This is something that you should know. Bromide, oxide, fluoride, iodide, minus 1 charges. This is an ionic compound. The plus 2 goes here. The minus 1, or the 1 and the minus 1 goes there. The formula for calcium bromide is CaBr2. This is ionic. Let's switch things up a little bit. MgSO4, this is an ionic compound. How do I know? Because magnesium is a metal, and SO4 actually comes from SO4 minus 2 if you use our flashcards, and that is the sulfate ion. Right? So if we want to reverse engineer this, we have Mg plus 2 interacting with SO4 minus 2. We do the switcheroo and we get Mg. Now this is not the right answer because it's not totally reduced, but when we reduce this, remember, always go for the empirical formula, we get MgSO4. All right, CrOH, and all of that OH is in parentheses 3. So Cr is chromium, and chromium is within the transition metals, and OH represents OH minus from our flashcards. So what is the charge of the chromium here in order for us to get CrOH3? It has to be plus 3. Right? So this is ionic. So the 3 goes here, the 1 goes there. We get CrOH3, and the charge is plus 3. But remember, it's in this box, so it's actually going to be designated as Roman numerals. So it's chromium 3, and remember OH is hydroxide. So chromium 3 hydroxide is the name of this formula. Finally, xenon tetrafluoride. All right, mono, di, tri, penta, hexa, octa. Okay, those prefixes that signify numbers, that should be an automatic flag for you guys to think covalent, sharing of electrons. Xenon in our periodic table is Xe. Okay, it's what's called a noble gas. And fluoride is a halogen, it's F. And tetra means 4, so the formula for xenon tetrafluoride is XeF4.